Hi, I am Dunk.
I am Pan.
And I'm Pao.
We are from Chulalongkorn University, Thailand, and we are going to present you project
Spectra
Southeast Asia platform.
for environmental change.
Tracking and remote analysis.
And here's the problem statement. There are three main tracking systems in the world right now, not only in Thailand or Southeast Asia. The first one, EU deforestation regulation. The second one is the GLAD, or we call it global analysis and discovery. And the last one is the technical data that's going to convert to the government data. And yeah, we have a lot of detector system, but we have a lot of data also. So here is this is why it's created IT system failure. So the data scaling caused a lot of problem, and also the speed and accuracy of the solution is not enough. So our solution Spectra want to fill in this gap between the satellite data and government data with accuracy, speed, and the times. So that's why we create Project Spectra.
So here's 4 current methods with our Spectra. First one, GLAD alert.
But it's not accurate.
Manual government monitoring.
But it takes too much time.
Handstand global forest change.
But it's not real time.
Commercial satellite services.
But it's expensive and unusable.
So with all of this limitation, we're going to implement a Project Spectra, and that's why we want to give a quick demo to you guys with Docker, Python, and Amazon Q.
Hi, and we are Spectra team. This is Spectra Core, Southeast Asia platform for environmental change, tracking and remote analysis. We built this for AWS Global Vibe AI Coding Hackathon to help analysts quickly spot forest, threat, and deforestation using satellite data and AI.
Spectra Core runs as a Streamlit web app. On the left, you see the data input panel and system status. In the main view, we have 4 workflows across the top. We have EFC Fusion, Enhanced Forest Composite from Sentinel-2 and optional SAR. And we have Change Detection, which is before and after deforestation detection. The third one is Agentic Insight, which is LLM-powered analysis of the vegetation health. And the fourth one is News, live environmental headlines related to deforestation and climate. On the top left, we also have an AI overlay selector that let us switch between different AI and demo overlays on the map.
So here we start with AI overlay. We have 5 tabs: EFC only, EFC AI detections, optical only deforestation probabilities, SAR fusion, and Lancet Edge forest cover. I will start with EFC only and using input mode as GEE, Google Earth Engine. As we see here, we select latitude and longitude, started and ended as Mac Cloud cover. We can change patch size from 512 to 2048. And then we click Fetch Sentinel-2 from GEE. We can also include Sentinel-1 C-band SAR. So then we click Run Fusion. And then we can see here is the picture from the satellite that we pull from GEE. And here we can see the red is the deforestation, the green is the forest, and the outer noise is the background. Then we move to AI detection. We can also choose in here to show raw AI marks for AI detection. It will show what AI's marks for output red, black, or green. So we can click Run Fusion because we already fetched Sentinel-2. And here we can see on the display here. The first one is EFC, second one is what AI detects, and the last one is the max. We can also click Run Fusion again. And also, after we get the output, we can save the output to train AI later. As we can see, the first one is not very accurate. So we can run multiple times and use the saved data to train AI to be smarter and smarter. Also, we can auto-generate to make this Spectra run Fusion for a lot of time without clicking manually. So if I choose the number of train and the number of well, I can now run autosave. After I click run autosave, it will save the time and send it into the server. And then AI will max all the picture, and then we can go edit the max to make it smarter and suitable for more spectra in the future. Also, we have optical only deforestation. You can see from the right side from the optical only deforestation model, the SAR fusion. This is still the demo, so the weight is still missing. We can train later to make the SAR fusion work. And the last one is Lancet 8. This one is also, the weight is also missing. But we can train it later. So we can combine all these 5 tabs to make the best AI to enhance image from satellite and analyze from that picture to make the work more easier and easier for workers. Next is the change detection. I will use GEE first and run the change detection. So this tab here is compare 2 satellite image picture from start and end date, and another one from another start date and end date. So we can click on here. Oh, we can fetch before from Google Earth Engine and run detection. So here we can see before and after, and it can detect how many polygon and area is changed over time. The third big tab is the agentic insight. Sometimes the user did not understand the output from the AI fully, so we plug in LLM to make user easier to understand the output from our AI and make summary so we can analyze it later. So here we can ask what is NDVI, We can also choose provider. I will use rule-based first. So here we ask what is NDVI, and it answer what is NDVI is. The last tab is the News tab. This is pull the API from news.io, and we can see the fresh news from every source. You can see this here from news source, from Scotland source, from Sky News source, and we can also focus on deforestation and land use, weather and climate. So if we want to see more of the news, we can click here in the link to read more news and use this data to work. So here we can see the disaster news. Yes. So here's all for Spectra. I will provide the link for anyone that want to visit Spectra. I deployed it in Streamlit Cloud so everyone can check it out.
And that is all for Project Spectra with Dunk,
ปัน and เปา
ขอบคุณครับ